Compound interest. If you've already watched the video, then you'll know that he talks a lot about how compound interest is unique because you are getting interest on the interest as well. So, simple interest, you are getting interest or you're paying interest on the principal only. But with compound interest, we are getting interest on both the principal and the already earned interest. Now, when we talked about simple interest, we said that the graph that represents simple interest would be a linear relation. If we graph compound interest, we would have an exponential relation. The equation that we have to represent compound interest, A is equal to P times 1 plus I to the power n. A is the same as before. This is representing the amount. We have P, which represents the principal, or we could say the original amount. We have I, represented as the interest rate per compounding period. Now, this is slightly different than simple interest because simple interest, we're talking about it per year, but this one is now per compounding period, and we'll talk a little bit more about that in a bit. N is representing the total number of compounding periods. So, there's a bit of peculiarities when it comes to compound interest because we're talking about the number of compounding periods. A period would be considered a segment of time. So, for example, if you enter into an agreement with a bank that is compounding money at a yearly or annual rate, you would be getting interest once a year. However, if you are talking about a semi annual agreement, then you're getting two compounding periods. Quarterly means four. So this is four times a year. Monthly is 12. Weekly, 52. Bi weekly, every other week, 26. And daily would be 365. Now, yearly, semi annually, quarterly, and monthly, these are the four most common compounding periods that you're going to see. Now, remember we said that I represents the interest rate per compounding period. So, what that means is over the year, it's going to give you 8% altogether, but not each time. If I have an amount of 8% interest per year compounded quarterly, my I would be 0.08 divided by 4, meaning that each compounding period in the year, I'm getting 2%. And since I've got four compounding periods in a year, 2 plus 2 plus 2 plus 2 gives me 8% in total by the end of the year. The letter N represents the total number of compounding periods. Now, when we talk about compounding periods, we're interested in finding out how many times we're getting interest in the agreement that we have. So, an example, an amount is compounded semi-annually for 5 years. What is the N? N represents our total number of compounding periods. So we're going to take 5 years and we're going to multiply it by 2 because in each of the 5 years, we're getting interest twice. So that means in total, I'm going to be getting interest 10 times. Let's do a few examples here. Sam is investing $3,200 for tuition when he goes to college in 2 years. If he invests his money at 6% per year compounded monthly, how much money will he have when he goes to college? Let's type out the information that I have. APIN. Now, I chose to use compound interest, the equation for compound interest, because in the question it says that the money was compounded. Every time you see the word compounded as part of the question, you know that we have to use our compound interest equation. Right, so back to the question. Sam is investing $3,200 in tuition. So his investment is what he has right now. He wants this money to grow for when he goes to college. We know that he is getting money 6% per year compounded monthly. Now, for us to type that in, we're going to have 0.06 and we need to divide it by 0.06 divided by 12 because the 6% is spread out over 12 compounding periods. That becomes 0.005, so half a percent each compounding period. Either way, you could leave it like this or simplify it. I actually find that leaving it as a fraction works better because some of the fractions, when you divide it out, ends up being a repeating decimal, and so you would have to round, which makes it less accurate than having the exact value. Finally, our n, we know that he is getting interest monthly and he's doing this for 2 years. So we have 2 years times 12 months in a year, and n is 24. So I insert this into my equation. A is equal to 3,200 times 1 plus 0.06 over 12 raised to the power of 24. Throw that into your calculator. Your answer should be 3,606.91. Pause the video for a sec to make sure that you're able to get the same answer using your own calculator. Question number 2. City Council voted to build a swimming pool in 3 years. They need to have $10 million to build it, and they have an opportunity to invest some money in a bond that pays 8.8 per annum compounded quarterly. How much should be invested? Now, $10 million. This is the final amount. We know that this is the final amount because this is what they need to have at the end of the 3 years in order to build the swimming pool. The question is asking how much money should be invested now. That means that we are looking for the principal. Now let's organize the information that we have. We know that A is 10 million. Principal is unknown. Interest as a decimal 0.088, but because it's compounded quarterly, I need to divide by 4 because our 8.8% is spread out over 4 payments in a year. And finally, our n is equal to the total number of compounding periods. We know that they're investing for 3 years, and each year they're getting money 4 times. Now we have 3 times 4, and that gives us a total of 12 compounding periods. Let's put this into our equation. A is equal to P times 1 plus I to the power n. So 10 million is equal to the principal times 1 plus 0.088 divided by 4 raised to the power of 12. This is an algebra question now. We need to rearrange this equation to isolate for p. So I'm going to take this monstrosity and divide it to get rid of it on this side. 10 divided by 1 plus 0.088 divided by 4 raised to the power of 12. And that's equal to our p. Pull out your calculator for this. And we have 7.7. The principal is equal to 7.7 million. That's what they need to invest right now so that they can have 10 million in the future. A debt of $6,000 grew to be 8,940 when you paid it off 5 years later. The debt was compounded monthly. What was the interest rate? Let's sort out the information that we have. A, P, I, and N. A debt of $6,000 grew to be 8,940. So the original amount, or our principal, $6,000. The amount, we have 8,940. The interest rate is what we don't know. However, we know that the interest rate is always going to be the rate divided by the number of compounding periods per year. This compounding problem is compounded monthly. So I will put R over 12. N represents the total number of compounding periods. So we have 5 years, and we're multiplying it by 12 because it's compounded monthly. That gives us 60. Put that into our equation. 8,940 is equal to 6,000 times 1 plus r over 12 raised to the power of 60. Now, this kind of question is inside the bracket. You can do algebra, but it's a little complicated. We can use technology to help. So if I'm using technology to solve, I have an exponential equation. We know that for equations, we can make two separate equations, enter it into a graphing calculator, and where the two graphs intersect, we'll have our answer. So the left side of the equation is y equals 8940. For the right side, 6,000 times 1 plus x over 12 raised to the power of 60. Let's go to our graphing calculator so you can open Desmos on another window. I'm just going to put this here for simplicity's sake. I'm going to enter each of the equations, the left side and our right side. And you'll notice that you can only see part of the equation right now. In fact, it's too small. Our field of view is too small for us to see this. I'm going to change my field of view. It's the y-axis that I need to have more. The y-axis, we know that it goes to 8,940 as a minimum. So I'm going to do 9,500 to see it better. Okay, the point of intersection, 0.08 and 8,940. Point of intersection 0.08 and 8,940. So for us to interpret this, X where is our yearly interest rate. So we have 0.08, that's represented as a decimal. Let's multiply it by 100 and we get 8%. So what's the interest rate? Interest rate is 8% per annum. Right. Another question similar to that. You've invested $1,500 at 5% compounded semi annually. How long will it take to grow to 2,000? Use technology to help you solve. We're going to do the same thing that we did for question number 3. We just need to write our equation and then enter the left side and right side separately into our graphing calculator. A, P, I, and N. You've invested $1,500. 1,500 is the original amount. How long will it take to grow to 2,000? 2,000 is our final amount. We know that the interest rate is 5% and it's compounded semi annually. So we have 0.05 divided by 2. And finally, n is the total number of compounding periods. Let's write the equation. 2,000 is equal to 1,500 times 1 plus 0.05 divided by 2, all raised to the power x. So the equation that we've created from the left side, y is equal to 2,000. From the right side, we're going to have y is equal to 1,500 times 1 plus 0.05 divided by 2 raised to the power x. Okay, let's start a graph. Y is equal to 2,000. Second graph, y is equal to 1,500 times 1 plus 0.05 divided by 2 raised to the power x. Now, I don't see anything on this graph because the numbers are too big for me to see in here. I know that the y value goes to at least 2,000. Let's change the field of view. The y-axis, let's make the top end 2,500. Okay, we already see a graph there. Click on it and we see that we have a point of intersection. The point of intersection, 11.7 and 2,000. Okay, so x, which is the n, is representing the total number of compounding periods. So we need to have 12 compounding periods to get to $2,000. Now, since we're compounding semi annually, this means that we are getting our money compounded twice a year. That means that if I have 12 compounding periods, this is going to be 6 years. Okay, so let's clarify that again. N is always equal to your years times the number of compounding periods per year. Now we know that we have a total of 12. We don't know the number of years, but we know that the number of compounding period per year is semi annually. That means 2. Now, when I rearrange this equation, we get years is equal to 12 divided by 2 or 6 years. Great. Try these two questions on your own. And then there are 2 pages of practice questions and answers on the last slide.